All right, welcome everyone. Today we're going to take a quick whirlwind tour of our home in the cosmos, the solar system. We're going to meet the planets, the moons, and all that other fascinating stuff that's floating around in between. So let's dive right in and explore our cosmic neighborhood. You've probably heard that famous quote from the great astronomer Carl Sagan, "We are star stuff." And you know what? That isn't just some beautiful, poetic idea. It's literally true. The very atoms that make up our bodies, our planet, everything in our solar system, they were forged in the hearts of stars that lived and died billions of years ago. When these massive stars explode, they blast essential elements like iron and nitrogen all across space, and those are the basic building blocks for planets and for life itself.
Okay, so before we start meeting all the residents of this cosmic neighborhood, we should probably get on the same page. Let's start with the basics. What exactly is a solar system?
So, at its very core, a solar system is pretty simple. It's a star, for us that's the sun, and basically everything that's gravitationally stuck to it. And I mean everything. We're talking giant planets, tiny little flecks of rock and ice, all of it, kind of dancing in this delicate gravitational balance around that one central star. And yeah, you guessed it, it all starts with the sun. I mean, it's the heart of our system, this massive ball of plasma that's just constantly generating light and heat. But its most important job? That immense gravity. It's the anchor that holds this whole shebang together. All right, now for the fun part, let's meet the most famous residents of our cosmic neighborhood. I mean, when you think solar system, your mind probably jumps straight to the planets, right? So let's start there. So what actually makes a planet, well, a planet? It turns out astronomers have this little three-point checklist. First, it's got to have a clear orbit around the sun. No problem. Second, it has to be big enough that its own gravity squishes it into a round, or at least nearly round shape. And third, and this is the one that's caused some debate, it has to have cleared its neighborhood. Basically, that means it has to be the gravitational bully on its block, the dominant object in its path. And what about moons? The more scientific term is natural satellite, and really it's just anything that orbits a planet. You know, here on Earth, we're used to just having our one moon. But it turns out that's kind of rare. It's actually way more common for planets to have a whole bunch of them. In fact, believe it or not, scientists have found over 200 moons just in our solar system alone. But here's the thing, that space between the planets, it is definitely not empty, not by a long shot. It's this wild, dynamic, sometimes even chaotic place, and it's filled with countless other objects that are just as important to the solar system as the planets themselves. So let's take a quick look at three of these other residents. We're going to talk about asteroids, which are like the rocky leftovers from when the planets were forming. Then there are meteoroids. They're smaller, broken-off pieces. And finally, comets, the icy visitors from way, way out at the edge of our system. Okay, first up, asteroids. You can basically think of these as giant space rocks. Now, the vast majority of them hang out in what's called the main asteroid belt. It's this huge ring of debris that sits right in the gap between Mars and Jupiter. And the prevailing theory is pretty cool. Scientists think this belt is made of all the leftover material that could have formed another planet, but the massive gravity of Jupiter, right next door, just kept it from ever clumping together. All right, so now if you break off a piece of an asteroid or a comet, you get what's called a meteoroid. And these little guys have a bit of an identity crisis, depending on where they are. Out in space, we call them meteoroids. But if one happens to enter Earth's atmosphere and burns up, that's what we call a meteor, or a shooting star. And if a piece actually survives that fiery trip and smacks into the ground, then we call it a meteorite. And last but not least, we've got comets. The best way to think about them is as these cosmic, dirty snowballs. They're just big clumps of frozen gases, rock, and dust. Now, for most of their journey way out in the cold, they're just frozen, inactive lumps. But as a comet's orbit brings it closer to the sun, things get exciting. It heats up. That ice turns directly into gas, and this process blasts dust and gas out into space, creating that glowing head and that absolutely beautiful long tail that can stretch for millions of kilometers. So this chart does a great job of laying it all out. You can really see the key differences here. A planet's main feature is that it's the big boss of its orbit. An asteroid is mostly just a rock hanging out in the asteroid belt. And the defining feature of a comet? Well, that's its icy nature, which is what gives it that spectacular tail. It's a really handy way to keep all these terms straight. Okay, so we've toured the block, we've met all the immediate neighbors. Now let's pull the camera way, way back and get a real sense of our place in the universe. You know, as huge as our solar system feels to us, it's so important to remember that it's really just like tiny, isolated island. The distances between stars are, well, they're almost impossible to wrap your head around, especially compared to the distances between our planets. Our entire system is just this little, gravitationally bound island floating in a vast, dark, cosmic ocean. And just to put that into perspective for you, the distance to Proxima Centauri, which is the very next star after our sun, is 4.3 light years. That means it takes light, the absolute fastest thing in the universe, more than 4 years to travel from our sun to the next one over. That number really drives home just how immense and empty interstellar space truly is.
And that really brings us to our final, big thought. We know our star is just one of hundreds of billions in our galaxy alone, and we're finding planets around other stars all the time now. So, if our little cosmic island holds all this variety, all this wonder, just imagine what incredible things are waiting to be discovered in the countless other solar systems out there. What wonders are we going to find in the next one?